All right, welcome back to Information Storage and Retrieval. Today we're going to rewind a bit and kind of zoom outside of the core, information retrieval system that we've been dedicating so much processing power to. And we're going to talk about a broader question of what are we aiming this system at? What are the issues that come up when we're trying to actually build a collection of documents. So overall, we've covered a lot of ground, right? We've talked quite a lot about what can and should be included in a search system, right? Well, all the different algorithms and data structures that contribute to building a system that can take the information need and the unstructured data and make results out of them. But we haven't talked about populating collections. And just the visual version of that is all this lovely stuff, right? We how to process these things, how to build different kinds of indexes for different tools, but collecting has still been kind of a question mark. So today we're going to talk about some ideas for how to build a collection, what it means to even have a collection. You'll understand that briefly, and what are the methods that we can use to, if we're trying to start using these abilities, these systems that we've designed here, how we can start aiming them at specific topics. So that includes two different concepts. First is, what does it actually mean to store a collection, and then what are some methods to gather documents into a collection. So first, let's talk about storage. We've really not been talking at length about what it means to store a collection, because so far in all the examples, they're just these little blobs of text that exist, right? In all the examples on the slides, it's been, oh, just here's some documents that are text, right? And even in the assignments so far, it's typically been, here are a set of strings, do things to them, right? But what does that look like if we're actually going to build a system that's handling something larger? If we're looking at a Google, for example. So there's three ways you can store a collection, and I'll tell you, only one of them is really super powerful, although two of them rely on the same concept. So locally in memory, so in your program's memory, like while it's running, it has all of the collection loaded. Locally on disk, where you're not storing them all the information directly in memory, but it's available on the disk for you to access, or online over the internet. Let's talk about each of these in turn. So one way to store a collection is locally right in memory, right? As our program is running, it has all of the text of all of the collection in memory. This, for example, this Shakespeare collection that I've used in examples in other classes it's just a list of strings, right? It's just from fairest speeches and desired increase, blah, 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 all the iambic pentameter you can want. So these are just strings stored in a variable inside a program that would also have all the rest of the features, right? All of the information storage, the indexing, all that good stuff. And this is fine for all the toy examples we've been working with. But in general, the way we've talked about documents, I think it's pretty clear. Documents are typically larger and more complex than just a handful of lines of raw text, right? So this is not really, it doesn't scale, for one thing. You can't store the Library of Congress in memory. It just doesn't work, right? So this is the most concrete way to keep all this information. But the idea now is that maybe we should be abstracting a bit. Maybe we shouldn't be storing the entire document text every time that we want to run any part of our search system. So skipping this, we can instead do local storage but on disk. So remember, indexes are powerful because they're flexible, right? Where each part of the index is stored is kind of up to you. It depends on how much you want to be accessing different pieces every time you need them. And there's best practices, I'm sure, but the idea is you can offload things when you need to. Meaning, the only thing you really need in memory when you are running a search is the dictionary. And also, in a lot of cases, depending on the size of your collection, the postings can fit too. Although, if you start to do positional indexes, that does get a little bit longer and longer. But again, those are the kinds of things that you would sort out when you need to. The idea is all of these things can be separated and stored for access only when you need them. So the documents themselves are so whether or not you do this with postings, that's a question for the design of your system. But the documents certainly can just be left on disk. And you would then only come back to them to grab their full text off the disk when you need to index them or when you need to show the results. And even then, not necessarily need to show the whole document in the results, right? You might want to show a snippet, or you might just want to link them to the location of the document. So what you can do instead is the idea of addressing, right? Of pointing to the documents as opposed to storing their entire text in memory. So you can say the collection can just be a list of addresses as opposed to the full text. And for example, instead of each line of text being stored in memory, which again represents an entire document, you could have it be to a file location. Users jkl sonnets line 1.txt. Now, scale that up, that could be an entire book. That could be a 70-page PDF, right? I wouldn't need to keep that 70-page PDF in memory every time I need to do the search. I could just access it by knowing where it lives, right? There's also a very simple way of considering this a collection as well, is then you could run your indexing on every file in some folder, right? And it would just kind of build itself. Neat, right? So that's the idea of it's a pretty important idea of using addressing, using references to find things instead of using the full text. Now, in general, local storage on your disk, right? This does require repeated disk access, but once it's done, it's done. When you are building the index, you're going to have to access the disk quite a lot. That's annoying, but again, remember that indexing happens once, and then from now on, we just have the list of all the addresses of the files, the locations, accessible for the search system. And you'd need to use these kinds of functions, so like read file functions. You should be getting familiar with these in general, but they matter. That's how you bring this text into your into your information retrieval system. And overall, this is great because it reduces the system load, right? It makes it so that there's a lot less going on in memory, and you're only dealing with the size of the individual documents when you absolutely need to. And it also makes everything more flexible, right? You can, instead of a single line of text per sonnet, or per line of the sonnet, a single file, again, that could be an entire book, a volume of an encyclopedia, whatever. So that's the idea of local storage on disk. Now we can kick that up a further notch into why store our collection at all, right? We can just use the internet, can't we? So and this is, okay, honestly, that's kind of a trick question because the internet is also just storing files as well, but we don't necessarily need to think of our indexing process as dependent on where this stuff is stored, right? You can index anything you can get your grubby little fingers on. And by that, I mean your lines of code, right? So if everything's available online, you can use web URLs, right? The same way that you go to websites, these are universally unique identifying addresses of where a thing lives on the internet. That's what the URL is getting at. And that's the same concept, right? So now if we just think of it in terms of, well, my collection is this list of URLs that I can keep track of, now we're getting to Google territory. Let's look at the supplemental text for this class, the Introduction to Information Retrieval textbook, right? It is available online fully as an HTML version of itself, so you can. It is itself also a website, which is nice. Still, again, you're not required to read this text, but it is a decent reference when you have a very specific question about this content. So, okay, so that's the web page on the left. You can see it's very simple. Chris Manning did not go all out on this presentation, but it's clean, it's simple, and it has lots of links. So from here, you can, well, I've also shown the HTML code of that particular website, right? That is the text of that document. It has lots of stuff in it, right? It has the body, it has the header of the HTML, you know, hopefully you've all at least seen some of this before. Has the H1, Introduction to Information Retrieval. You see that at the top of the page, right? Further down, you have all the paragraphs, you start seeing some of the links, all that stuff. Okay, cool. This is a web page. That shouldn't be a surprise to anybody, but that's what this is. If we want to get this text to index it, we can do that. So this is going to be a Python example for reasons I will explain near the end of the talk. So just follow along. So this is a Python shell, and it's saying, okay, we're going to import this URL lib request. I'm going to store this. Oh man, there's lots of code. Let's look at it. So URL lib request, and it has a function, a method URL open. So it can open the web page for this document that we just saw, right? I save that into a web page variable, and now I can call webpage.read. What do you think is going to come out? The HTML. We've just done the same thing that every web browser in the world does when it says, "Hey, yo, I need to render this page. Give me the code." This is ugly as sin. We can't see make much heads or tails of a lot of it, but that's only because it's removed all the white space. If we clean it up, we can see, like, we've just added some spurious white space. This is the page, right? And again, the things that we might want to document inside that page, the things we want to index inside that page, are in all of the visible things in the body. There. If we were going to index that web page, this is the kind of stuff that we would strip out of it. We would pull out, we would extract that text and say, okay, this is the stuff that matters to the user, to the reader, to the person using my search system. So that's just showing the basic idea of it doesn't really matter where a document is stored, so long as you know how to get to it and how to pull the correct information out. So again, we're doing the same thing as we did on local documents. We're using links. Our collection is composed not of document text, but of links to documents. So now we just store those and access those documents as needed. So this brings us down to, this is just to illustrate the fundamental idea that storing things locally in memory is not great. That's good for toy examples and demonstrations and everything that we've kind of played with so far. You wouldn't do that on a real system. What you would do on a real system is you would use links. You would connect your indexing process, your indexing system, your information retrieval system would be connected to some existing collection by way of links to things in it. And both locally on disk, that's fine, or online. Whatever you have, your document collection is just a bunch of links to wherever they live. You can even mix and match if you want. If you want to have a system that can search locally and online, great, fine. You can have a collection composed of both URLs and file locations. Thumbs up. So that's the idea. It makes everything a little bit more adaptable. It makes everything kind of make more sense broadly, I think, because now you can access any kind of file, not just text strings that we've pre-programmed into our system. So, in general, remember, when we're talking about how we store our collection, remember that indexing is about creating a new structure. And this is just to help you kind of divorce the idea that the collection is sort of the same thing. It's not. The index is designed to be used without needing to look at the documents in real time, right? I can use the back. If you ever, open the textbook and look at the index section, you don't really need to know what's on each page to use the index for your search. You could even note down several pages you might want to visit, and then you spend the effort to go find them, right? So ultimately, an index is its own thing, and it doesn't care where the documents are stored so long as it can access them, so long as it knows how to point you to where they're going. So that's that, and the only time you really need to access the documents are when you're indexing or when you are evaluating the search queries and generating the search results, and even then, not always, right? The primary currency of Google is its 10 blue links, right? That it shows up on that first page. It doesn't need to show you the full document, although they often have snippets. So that's the idea of some of the important ideas that help us consider how a collection can be composed. We can also now talk about how actually do I go about building one of these. So, okay, I just stepped on my own toes here. That's how collections can be stored. Links, remember, links are big, and you can do them locally or online, doesn't matter. Wherever they are, they live somewhere, we can find them. Now, how do we gather them? So, we're going to talk about 4 different ways. And they're all related, obviously, but they have their subtle distinctions that help make them more clear for different use cases. So, manual, existing curated collections, API access, and web crawling. So as this goes forward, it's a little bit more and more general. Manually building a collection. This is the most straightforward and adaptable way to build a collection, but it relies on you as a central component of the process. That means it cannot scale, obviously. You're not going to be doing this to collect 100 million documents for some specific purpose, right? Fine for a class project, fine for examples that we might do, but, and in fact, to be clear, that's how I've done all the examples so far. I wrote a stupid poem about my cat, I found some Dr. Seuss lines, all that good stuff. So, but that's not how you would build a system. So again, though, what are you doing? You are manually sorting through websites, PDFs, piles of documents, and you're finding all the information or text that you want to save, and you're storing it somewhere yourself, right? That's fine. It works. That's good. But that's not how you would do this if you were trying to build something towards a specific application. A different approach that is nice because someone else has done all this for you is curated collections. So there are tons of sources out there for collections of data sets and or document sets that are ready for you to use. They're open access, so more or less freely available. A lot of them are like public repositories, that kind of thing. So the idea is that someone else has done some of this collecting. They found an interesting set of information that now someone else is free to use. But remember, going into these, that we're mostly looking for text, unstructured data. Just because that's the kind of processing that we have been talking about, right? We're talking about how to really turn text into these different forms to be searched. Not to say that you couldn't build a decent search system that incorporates the metadata and the numerical data, but okay, that's all beside the point. Ramble on. here's some examples from Wolfram Alpha. If you've heard of them, they're a big information group out there, and they have a data repository site that allows you to search. And again, because we're looking for text, we can actually specify that in this specific system. So they have collections of various things, you know, and it's very nicely organized. That's where I pulled the sonnets from originally. There's every State of the Union address, right? Other big speeches, blah, 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 right? These kinds of things available. And the reason you care about this, you should care about these collections, is that, for one thing, they can give you ideas, right? They are nice, clean sets to you can test a system on. You can also get ideas for what kind of system might be needed out there. It's nice to see collections like this just set up side by side. To dig deeper into this specific data repository, the Wolfram Cloud one, you could see, if you dug into Shakespeare's sonnets, you could see the structure it has, right? Gives you a nice little word cloud of its information. And it's all text, right? So the objects inside of this particular collection are the lines of text from the sonnets. I believe this one's split up into, it may be split into stanzas, or it might be split into full sonnets. I don't remember the structure of these dang things. So that's the idea. You could download this data set and begin building a system on it, right? And again, it can be useful as test systems too, as test sets. When you go to build your index, you might have questions about how it's going to work on a new, like a data set that you don't know about, right? So we can't just use green eggs and ham forever, right? So, okay. But if we want to get more complex, there's other very interesting ones available in the same sets. So this one this is a U.S. health data breaches. So these are multifaceted data sets. They have all kinds of information, lots of fields. They have descriptions, so we still have plenty of unstructured data to pull from, but it also has who's involved, what companies were involved. You could build a system that could take these U.S. health data breaches and make them more accessible to the average user, doing some interesting, helpful search systems for your users, web of trust type stuff. So this is just to show that these kinds of things are out there. They're kind of fun to roll around in and just scope out and figure out how you would maybe tackle one of these systems. But they exist. So, okay, that's somebody else doing a lot of work for us, right? And that's good. I mean, I'm not meaning to call us lazy. That's friggin' great. But go, take and give back, right? But if we don't have these available, and we know we have a specific kind of format or a specific source that we're interested in trying to build a search system around, we can instead look to APIs. So, application program interfaces. So if you know that your source is the sources for the data you're interested in trying to build a search system around, if you know they come from a particular website, for example, but there's no curated collection already been compiled for you, they might have an API, which is application program interface. These are tools that allow your program, your system, your document collector, whatever you might be using, as in you would write your own little script, right, to go and get these things. They have calls you can make. You would specify a specific URL format, and as in there's like a specific construction that you would have to make the call using. You throw it out to their web server, and then it dumps back information of a particular category or kind or search criteria, right? And to use these, you'll need to register with the platform and get some kind of access key. What exists, right? So what might we use these on? Music Match, for example, has an API for accessing lyrics, right? So you could go to Music Match and gain access to their API, and you could build a script that would start collecting all of the song lyrics for, I don't know, a particular artist or a particular genre, right? Or a set of genres. Say you want to make a genre-specific music lyrics search system for whatever reason, right? Because you can always add more features to make this kind of custom and specific and interesting. But that's the goal. That's the idea. You can also do the same idea for Reddit. You might want to scrape certain types of posts from a particular set of subreddits or something. New York Times, maybe you want to gather all the articles from a particular year range, right? Under the op-eds in a particular era, whatever. Twitter, they have a really advanced one. You can really access a lot of kinds of tweets using different parameters. You can say, hey, I want all the tweets from these geographic locations in this time frame that have these hashtags, that kind of stuff, right? So this is a way you can go out there and still using a very structured approach, right? So not necessarily as tight as somebody already doing all of it for you, but more broadly, you can say, hey, pull these back, give me access to some of your data. An example of the New York Times is showing, okay, one of the calls might be to get a specific, you provide your key, yada, yada. So you would get back a specific document's text, right? And you might need to then save that. But at least you would get its link as well, right? So same idea for Twitter. So you would maybe... They have this system called TweetDeck, I believe, that you need to use to be able to pull information more easily. I don't know. It's them attempting to restrict your access, honestly. But the idea is, again, you can use their tools to go and retrieve a set of information that you think is relevant in some way. So that's APIs. This is the idea of, it's more flexible than curated collections. And it requires a little bit of work, but and learning the API itself, of course, how exactly it works. But it allows you to really not super rapidly, but pretty easily gather large amounts of specific kinds of information. I mentioned not totally easily because they are actually typically rate limited, so you can't just like get 100 billion tweets from Twitter. They're going to say, hey, you can have 200,000 per hour or whatever, right? So, but that's the idea with APIs. The final answer, the final option that we'll talk about is the broadest approach. And this is, again, this goes really nicely with the unstructured approach, right? We are talking about random documents all over the world. We might want to find a way to just automate a search, a physical, like not physical, but a crawl, if you will, web crawling. So let's say you have information out there in the world that has neither a nice curated collection nor an API. It doesn't have any way for you to easily access anything. It doesn't have any specific, no one has already done the effort of collecting this stuff. There's no repository that saves it. We can build our own web crawler. And this is how Google started its thing, right? Having a web crawler out there, moving around pages, finding links, and saying, hey, here's a page. Oh, here's another distinct page. I'll save that too. So that's the idea of crawling the web. So nearly every modern web page contains links to other things. Of course, some of them don't. Some of them are dead ends, right? They don't even have backlinks. Some pages are more like hubs, right? They contain almost entirely links. So like the front page of New York Times will have connections to a whole bunch of articles and not much in the way of content of its own, right? These are just pages that exist mostly to link to other pages. Whereas other pages are more about the content. So what web crawlers are trying to do is, it's okay with finding those hub pages, but it's trying to find all of the content. So you start from the one page, You go explore all the connected pages, and then you start to build your collection of links. So let's do a little example. Here's how we would build out a collection of links to different pages. You'd start your collection and say we would seed it with page A, right? Page A is one random page on the internet. We don't know much about it, but the question is, how far can our web crawler get from just this one seed? So say page A links to page B, another similar page of its same type, say a different article, for example. Page B, add that to our collection. We might search that later, right? Page C is also linked to by this page. Great. So this is a page that, again, is in the same category. And again, these are things that we might continue to search by. Those have potential other links to other places. But, ooh, we've hit a gold mine. We found a hub page. Great. Hub pages, now we might index this as well, right? Whether we determine this as an exact part of our collection or just sort of a meta document is up to us to decide. But ultimately, this is still going to help us find a lot of content pages, right? So from the hub page, it might have links to tons of pages. So pages A, B, and C, which we've already covered. We're not going to add them to our collection again. But page E and D, hey, those are brand new. Let's throw those on. And then even that hub page might fortuitously link us to yet another hub page, a different related topic that has its own set of pages that are all connected. And so on, builds a collection, right? So by exploiting the linked nature of web pages on the internet and just dedicating a process to kind of doing this same little check over and over. Hey, look at a page, find its links. Look at a page, find its links, continue on in that fashion. We can spread out pretty dang far into the internet. Now, how far we decide to go is up to the way we design the web crawler. But it is, in essence, this tiny program that tirelessly walks the internet, right? All alone, finding pages and saying, ooh, that looks good, ooh, that looks good, and adds them all to our collection. So it's this very flexible way to automatically run across the internet gathering links. Now, we may want to set some parameters, like I said. So you can restrict them to, say, very specific domains, right? We might not want to allow our web crawler to jump, for example, anytime a web crawler would bump into Wikipedia, you might want to stop it there, right? We don't need to be indexing all of Wikipedia. It's already done that. We can, if we want. We can index a specific subset of Wikipedia for some reason, but we might not want that in our whole system because there's a ton of information there and it's already its own sort of searchable system. So we might want to put a wall up, right? So you could restrict to one specific domain or omit other domains, right? But we can also make use of metadata. In the head of most HTML documents, you have a lot of different little meta tags that are defined. And one of them, often, in certain constructed websites, has the next tag, which explicitly the website creator knows there is a structure to the way these documents flow. I will include the next tag, which allows for some default behavior within web browsers. But yeah, so this allows you to prioritize crawling next tags because you know they're going to stay relevant to the current search. That doesn't mean you wouldn't search other links that you find. It's just that those could be more important or more useful. An example of a next tag is that in the information retrieval website, right? We can see they have defined from the top level, where this is the overall introduction to information retrieval book website. The next page will be node 1, which is the first page, quote, page of the book. Okay, so that's the idea of web crawling. It's this little flexible automaton that builds collections, right? Its whole job is to crawl around the internet and add pages that it finds. And Google does this. This is their thing. This is their jam. This is their bread and butter. They will crawl and crawl and crawl millions of documents, millions of web crawlers maybe, depending on what their resources load looks like. And they're trying to index as much of the internet as they can find. You probably don't need to do that. Google's already doing it. But this is how they do their job. At the same time, something you may not have noticed is that there are gaps. There are places online that intentionally exclude themselves from crawling. Sometimes that's for privacy, sometimes it's for more nefarious things. But as an example, these YouTube videos, for example, they have settings turned on that say don't index these with the rest of YouTube. Don't, just because they're not for the public, right? This is for a course. I wouldn't mind them being for the public, but I also don't need the comments section to blow up with trolls. So the point is that there are reasons that certain places are not indexed, and you could still use this process to index them for your specific purposes, right? These broader things are more for just like, don't tell the whole world about these web pages. But you could still, in fact, you might need to build your own kind of search system for places that are not indexed by a Google of the world. So let's say we want to build one of these. We're not going to dive into depth. I just wanted to give sort of an overview of how you would scaffold this. How would you put this together at the sort of structural level? So if you want to make one of these yourself, the basic loop is grab the text of one web page, any specific web page. It might be best to start with a hub if you know it exists for the content you're working on, but start with a web page. And then you would fetch the content, right? And obviously maybe omit certain of its links, but you would find all the links on the page. And then you'd repeat this process on each of those links, right? So it's really just that. You grab the text, find the links. Grab the text, find the links. Later on, you can then start the indexing process. But for now, it's just about, hey, grab this, find the link. Grab this, find the link. You can repeat that for each link. And you continue until, whatever your decision is. It hasn't found a new page in a while. It must have crawled the whole connected network of pages that I pointed it at. Or maybe it's just like, I found 500 million entries. Maybe I should stop. I don't need more than that. There's any number of reasons or ways to stop it. So let's talk about each of these. So fetching web content, as I mentioned before, is, the way of you use the URL to go get me the document text. Programming languages all typically include a tool to let you do this. It's essentially just load the text or HTML, whatever, of a remote web page by way of a URL. And this is typically just called fetch. This is the way you fetch things. To do fetching with Java objects, you would need the URL object, URL connection object, and the buffered reader object. To do it in Python, you would need one of these various libraries that exist for it. I showed them before, URLlib, right? URLlib can open a request, open the site, and then read the lines of the text off of the site, right? In both of these cases, we're still using a reader, just like you might on a raw file. Now, there's a notable omission here. Why no JavaScript? We've been doing everything in JavaScript. We've been talking about how key JavaScript is to this curriculum. Why can we not do this with JavaScript? Quick history lesson. As it turns out, back when we would allow random web pages to run scripts that would open any other random web page on the internet using these fetch calls, turns out that was a bad idea. Because you can really abuse that. You can make any web page look like any other web page. You could, any link that you open. I mean, you think about all the stupid, crappy pop-ups you get now, let alone if we didn't have something stopping this explicit abuse. So all modern web browsers respect the same origin policy, or SOP. So here's the policy of the day to think about. So the idea is that any script running on a specific web page can only fetch data, and I say that fetch generically, that's not exactly the way you do it. From any other web pages, you can only get them from the same domain. So that is, if my script is running on cs.oswego.edu, it can only fetch and load other web pages from cs.oswego.edu. That could be any one of your pages, because we're all kind of openly on the same little origin. And in fact, one could make a search system for cs.oswego.edu. Neat. And it would work easily because you could crawl it very easily, right? But the idea is that this prevents that scripting from doing a lot of different things, going to other web pages and snatching sort of sensitive core processing stuff from the DOM, from like the actual web page construction information, and also from like pretending to be other pages, right? Imagine if you could, on your crappy like Bitcoin miner website, load Facebook and then have grandma using Facebook through a Bitcoin miner for her entire rest of her life. So we don't want that. We don't want these things. We don't want to make it that easy. So then, but that's kind of a weird thing, because why are we only restricting JavaScript? Why not Java and Python and other things that are trying to load random web pages? And what it comes down to is that JavaScript, despite being sort of the scripty language of all things internet based, it's the primary language that web pages use to do anything interesting. So while JavaScript feels like it would be like the best at this web crawling game, it respects this SOP as a sort of speed bump to make it harder to abuse these things. And, for the typical use case, it does make it too hard to jump through all those hoops. It's not impossible to load other pages' information. It's just have to do it with additional resources and more development kits and tools and stuff. So this SOP just helps to sort of put up a fence. People can still leap that fence, but it's still, hey, at least it's there. And then, so the other idea here is that it's not trying to prevent all possible web scraping and web crawling technology from doing its job. Otherwise, we wouldn't have Googles, right? But in most cases, these aren't designed to run natively on a web page that you load, and it's not easy to achieve that. I mean, it is if you've done it, but it's not easy to achieve that from a base level. So it's more acceptable to allow these kinds of tools to just go and do the fetching and the scraping and the crawling, just because they can't then turn right around and give that to some user, some unsuspecting user, right? Because these are programs that are running not on a web page, they're running on their own. Okay, so this would be a basic web crawler. This is sort of a pseudocode with annotation. Here's how I would tackle it. So whatever language you use, other than JavaScript, obviously, in your script, you would set some collection variable, just sort of a list, an array, with just the seed link in it so far. So if our collection is a growable list with just the string somedomain.org in it, right? And then you would loop the following process for each uncrawled item that you have in your collection. So you would fetch that page's HTML and then search that text for example, maybe next properties in the metadata, but also maybe just any URL you find on the page, whatever your goal is for how you want this crawler to flow through the internet. And then if that URL is one that isn't yet in the collection, you add it and you go back and you find another thing that has not yet been crawled. Though I should add, you would wait a few milliseconds between each of these requests, because you don't want to flood a website with HTTP requests. That's called DDoSing, distributed denial of service, and you don't want to do that by accident. And especially because they'll probably ban you from trying to request from their site. So, courtesy delay. Eventually, your collection will have grown to the point that you have either found all the connected documents in the web space, and there's nothing left to search, or you've decided that you've reached some cutoff point that you defined. Either way, you now have a large collection of URLs that are all connected in this one kind of domain, this one web space, this one kind of interconnected set of loosely related material online. So That's it. That's the sketch of how you would set this up. Again, the details will be left to a more in-depth investigation. I'm not sure that we'll get to a web crawler in our building tools exercises, but we'll see about that. So, building a collection, we have now covered a few ideas, right? You have lots of options available. You can just do it yourself, which is bad to do, but fine to play around with. You can find curated collections that exist already. So a handful of sets that people have already done this gathering process in some specific way that's useful. You can use API access to sort of, from known sources, they have their own way for you to interface with their collected data for different subsets. And then just in general for web crawling, you can build a web crawling tool to do this automatically, do the full searching process automatically. Now, again, you might end up with a lot of junk in your web crawl, but that's up to a different process to weed out. And either way, what you end up with is a fully built collection of links. So, today we looked at how we can represent collections in our information retrieval system, and particularly as a set of links is probably best. And then ways to gather documents into those collections by, using the manual approach or the existing data, in somebody else's, and just creating an automatic tool to do it for us. So that brings us to the final thought. What's a collection of information you really wish was better searchable? Is there an API for it? An existing collection? Think you could build a web crawler? All right. Thanks. Take care.